In this example, we're talking about a company that packages sugar in 1,000-gram bags, but you took a sample and you weighed them and you found that the sample mean is actually about 1,010 grams and that the standard deviation is 20 grams. So the first thing we need to do is label our normal curve so that we can answer the following questions. So the mean goes in the middle, so that's 1010 or 1,010, and then going to the right I'm going to be adding 20, so that would be 1,030, 1,050, and 1,070. And then going to the left, I'll be subtracting 20. So that would be 990, 970, 950. All right, question A asks us what percentage of the data falls between 970 grams and 1,050 grams. So I see those two numbers are on my normal curve, which is really good, because if we didn't see those numbers on the normal curve, we would know there was a mistake somewhere. But it's asking me for percentages, and I don't have those written in yet. So let's go ahead and do that. The two biggest sections are each 34%. The next sections are each 13.5%. Then we have 2.35%, and finally 0.15% on the very, very ends. Okay, so what percentage of data falls between 970 and 1050? It would be all the percentages that I'm highlighting in yellow that are in between my two numbers on the horizontal axis. So in order to calculate my answer for part A, I would do 13.5 plus 34 plus 34 plus 13.5. So now you could take that and put that in your calculator, and it would give you 95%. Now, some of you may have been able to get that faster, without having to add them all up. And the way that you may have been able to do that is because if you noticed that this was two standard deviations to the left and to the right, and using that empirical rule, that's one of those percentages that you have memorized, is that from two standard deviations from the mean represents 95% of the data. All right, next question, what percentage of the data falls between 990 and 1070? So now we're looking at this one that I'm highlighting in green, 990 and 1070. We can't use that empirical rule for this one. The reason is because it's not symmetrical. 990 is one standard deviation away and 1070 is 3 standard deviations away. So that empirical rule is not going to help us. But what we can do is just look at all of the percentages that are in between those green numbers, and that will give us what we're looking for. So I'm going to highlight the 34, the 34, the 13.5, and the 2.35. So all those numbers that are now highlighted in green are in between 990 and 1070. So now I'm going to take all those percentages. So 34, 34, 13.5, and 2.35. That, if I add up all of those percentages, that's going to give me the percent of data that's in between 990 and 1070. And that comes out to be 83.85%. Okay? Now the last question is what percentage of the data falls between 990 and 1050? So I'm going to use a different color highlighter now. So here's 990, which is already highlighted in green, but I'm going to try to go over it in blue. And then I want to go to 1050, which is already highlighted. Okay, so the two that have kind of a blue circle around them. I want to take all the percentages that are in between, and I'm just going to do a blue bar on top because I've got too many colors overlapping. So all the sections that have a blue highlighter in the section, I'm going to add all of those together. So that would be 34, 34, and 13.5. So if I add those all together, that gives me 81.5. So that's the percent of the data that falls in between. And again, we could not have used the empirical rule because those numbers were not a symmetric number of standard deviations away from the middle.